everyone, welcome back to WarTech Vanguard. 3 massive eyes in the sky, suddenly blind. No missile launch. No explosion, no radar warning. Just silence. In modern warfare, the aircraft we're about to talk about is supposed to see everything, every jet, every missile, every movement hundreds of miles away. It is designed to be the ultimate guardian of the skies. Yet there was a moment when even this flying command center could be rendered useless in seconds. Imagine spending hundreds of millions of dollars on the most advanced surveillance aircraft on Earth, only to realize that an invisible signal could turn it into a flying spectator. Here we are diving deep into one of the most fascinating and shocking pieces of military technology ever built, an aircraft that controls entire air wars from the sky. From the outside, the aircraft looks unusual, but unmistakable. A massive circular radar dome sits above the fuselage like a giant disc balanced on 2 supports. That structure alone makes the aircraft instantly recognizable anywhere in the world. The aircraft is long, wide, and heavy, built on the structure of a commercial airliner, but transformed into something far more powerful. Its wings stretch across the sky, carrying 4 large jet engines capable of lifting this giant machine high above the battlefield. Painted in simple military colors, it may look ordinary to someone on the ground, but in reality, it is one of the most sophisticated flying systems ever created. The radar disc above the aircraft slowly rotates, scanning the skies in every direction. Each rotation sweeps hundreds of miles of airspace, constantly searching for aircraft, missiles, or anything that could pose a threat. Inside the aircraft, the atmosphere is completely different from what people imagine when they think of a plane. Instead of passenger seats, the interior is filled with electronic consoles, glowing screens, communication systems, and highly specialized equipment. Operators sit at their stations monitoring radar images and streams of real-time data flowing in from sensors. Every person on board has a specific responsibility, whether it is tracking aircraft, coordinating fighter jets, monitoring threats, or managing communication with ground forces. The environment is controlled, quiet, and focused because every decision made inside this aircraft can influence an entire battle taking place hundreds of miles below. What makes this aircraft truly extraordinary is its performance. The radar system mounted in that rotating dome can detect aircraft flying at low altitude from hundreds of miles away. High-altitude targets can be seen from even farther distances. The aircraft does not simply observe the battlefield, it controls it. From high above the clouds, it can track hundreds of targets simultaneously, identify which aircraft are friendly and which are hostile, and guide fighter jets toward threats with incredible precision. Pilots in combat often rely on the information coming from this aircraft because its radar view is far wider and more detailed than anything mounted on a fighter jet. The aircraft can remain airborne for many hours at a time. Without refueling, it can stay in the sky for around 8 hours, but with aerial refueling, it can continue operating far longer. This allows it to maintain a constant watch over a region, acting like a permanent eye in the sky. Its communication systems link together fighters, ground bases, naval ships, and command centers into a single network. In modern air warfare, information is power, and this aircraft serves as the central hub that distributes that information to everyone involved in the operation. Safety and survivability are critical for a platform this valuable. The aircraft carries advanced electronic protection systems designed to defend against jamming and interference. Its radar can change frequencies rapidly, making it difficult for enemies to disrupt the signal. The communication systems use encrypted transmissions and frequency hopping techniques so that hostile forces cannot easily intercept or block them. Multiple redundant systems are installed throughout the aircraft so that if one component fails, another immediately takes over. Operators are trained to recognize electronic attacks and respond within seconds by adjusting radar modes, communication channels, and signal filters. Despite these defenses, military engineers constantly work to improve the aircraft's electronic protection because modern warfare increasingly targets the invisible electromagnetic spectrum. Instead of firing missiles, adversaries may attempt to confuse radar systems with deceptive signals or overwhelm communication networks with interference. To counter these threats, upgrades are regularly installed that improve signal processing, strengthen encryption, and enhance the aircraft's ability to detect electronic manipulation. These improvements ensure the aircraft remains one of the most resilient surveillance platforms ever deployed. Another reason this aircraft stands apart is its unique role in military strategy. Few platforms combine surveillance, command, and communication capabilities in a single system. It acts as a flying headquarters, allowing commanders to observe the battlefield in real time and make rapid decisions. Fighter pilots depend on it to guide them toward enemy aircraft. Ground forces rely on it to warn them about incoming threats. Naval fleets coordinate with it to maintain awareness of the airspace above them. In many ways, it functions like the brain of an entire air operation. The radar technology itself represents decades of engineering innovation. By rotating continuously, the radar dome scans 360 degrees around the aircraft, building a constantly updated picture of the surrounding airspace. Sophisticated software filters out background noise and identifies meaningful signals. The system can distinguish between different types of aircraft and track their movements with remarkable precision. This allows commanders to anticipate threats before they even approach the battlefield. There is also a powerful strategic advantage to having such an aircraft in the sky. When deployed during military operations, it dramatically increases situational awareness for Allied forces. Instead of relying solely on individual radar systems, an entire region can be monitored from a single airborne platform. This unified view allows forces to coordinate complex missions involving multiple aircraft, ships, and ground units simultaneously. In fast-moving combat situations, that level of coordination can make the difference between success and failure. However, the aircraft's incredible capabilities also come with a significant cost. Building one of these flying command centers is extremely expensive. Estimates suggest that a single aircraft can cost hundreds of millions of dollars to produce, depending on the specific configuration and upgrades installed. When maintenance, crew training, advanced electronics, and operational support are included, the total life cycle cost becomes even higher. Maintaining such a sophisticated platform requires specialized technicians, continuous upgrades, and complex logistical support. Despite the expense, many nations consider the aircraft essential because of the strategic advantage it provides. Having a persistent airborne surveillance platform means can monitor large areas of airspace without relying solely on ground radar stations. And regions where terrain to geopolitical boundaries limit ground-based detection systems. The aircraft effectively extends the radar horizon, allowing threats to be detected earlier and responses to be coordinated more efficiently. In the broader context of modern warfare, systems like this highlight how technology is reshaping the battlefield. Information dominance has become just as important as firepower. The side that can see the battlefield more clearly and communicate faster often gains the upper hand. Aircraft like this serve as the backbone of that information network, linking together sensors, fighters, and command centers into a unified system. Even decades after its introduction, the platform continues to evolve. Engineers are constantly exploring ways to enhance radar sensitivity, improve electronic defenses, and integrate new communication technologies. Each upgrade strengthens the aircraft's ability to operate in increasingly complex environments where electronic warfare and cyber threats are becoming more common. The goal is simple but challenging. Maintain the ability to see, understand, and control the skies before anyone else. In the end, This aircraft represents one of the most powerful tools ever created for controlling airspace. From its distinctive radar dome to its advanced electronic systems, every part of the design serves a single mission: maintaining awareness of the skies and coordinating the forces that defend them. While the world often focuses on fighter jets and missiles, it is platforms like this that quietly orchestrate the entire operation from above. As technology advances and the battlefield becomes more complex, the importance of airborne surveillance and command systems will only continue to grow. These aircraft remind us that modern warfare is not just about speed or firepower. It is about information, coordination, and the ability to understand the battlefield before your opponent does. And that brings us to the bigger question. If the skies are controlled by the platforms that see everything first, what happens when those eyes are challenged by new technologies? The race to dominate the electromagnetic spectrum is only getting more intense, and the future of air warfare may depend on who can master that invisible battlefield. If you found this breakdown fascinating, stay with WarTech Vanguard, because we explore the technology, strategy, and hidden stories shaping modern military power. The next episode will dive even deeper into the machines and innovations that are quietly redefining warfare around the world.